Today we're going to be showing you how to design passive versus active high-pass filters. So first we've created a set of rules that you can generally follow whenever given a problem like this. So first you're going to read through the problem and determine if the circuit will be passive or active. And we'll go into a little bit more detail about this later about how you can tell which one it is. And then you're going to want to make a sketch of that circuit so that you can use it as a template throughout your problem. So next you're going to choose your capacitor value to base the rest of your circuit around. Number 3, you're then going to solve for the first resistor R1 using your given cutoff frequency and chosen capacitor value. And then for the next 2 steps, 4 and 5 are only going to be for the active high pass filter because it'll have the op amp. So step number 4, you're going to use the given V in and V out in the gain equation to solve for the gain of the active high pass filter. And then in step 5, you're either going to use the inverting or the non-inverting gain equation to find your other 2 resistor values, RF and R2. And then finally, once you have all of your values, you can redraw your circuit and plug back in the values. First, we're going to start with an example of a passive high-pass filter. So the problem reads, design a high-pass filter with cutoff frequency FC equals 1 kilohertz. Let Vin equal 10 volts and V out equal 100 volts. Identify the resistor and capacitor values. So starting with step 1, we, even if it wasn't given it to us, we could determine that this was a passive filter because we aren't given any frequencies for the input voltage, so we know that there won't be any power or any op amp. So we're going to draw out a template to use of a passive high-pass filter. So it'll be our input voltage, a capacitor, a resistor, and then our output voltage. So step 2, we're going to choose any capacitor value. So since we can choose anything, we might as well choose something pretty simple to use to make our algebra easier later on. So we're going to set C equal to 1 microfarads. Next, step number 3, we're going to solve for the resistor value, which is our R1 right here, using our cutoff frequency. So the equation for cutoff frequency is FC equals 1 over 2 pi RC. So since we know our cutoff frequency is 1 kilohertz, we can plug that in and then plug in our capacitor value. And rearranging this and solving out for R, we would get 159.15 ohms. So since we don't have to use step 4 and 5, since we don't have an op amp, these are all the values that we'll need, and so we'll just plug these into our template. And that is how you can design a passive high-pass filter circuit.
So next we're going to design an active high-pass filter, and the question is to design a high-pass filter with cutoff frequency FC is equal to 1 kilohertz and let Vin equal to 10 volts with a 5 kilohertz frequency and let V out equal to 100 volts with a 5 kilohertz frequency, and we have to identify all the resistor and capacitor values. So we know this is an active high-pass filter because the input and output frequencies are given to us, and because it's an active high-pass filter, we're going to have to include an op amp in our circuit. So this is what the template would look like. Next, we're going to choose a capacitor value, and you can choose any value just to make it easy. We're going to choose C is equal to 1 microfarad. And next, we're going to plug it into this equation to solve for the resistor value. And we know that our cutoff frequency is 1 kilohertz and our capacitor value is 1 microfarad. So after you solve this out for R, you get R is equal to 159.15 ohms. Next, we're on step 4, and we're going to use this equation to solve for AF, which is the gain for the active high-pass filter. We have all of these values. V out is 10 volts, or V out is 100 volts, V in is 10 volts, F is 5 kilohertz, and FC is 1 kilohertz. So we're going to solve all of that to get AF. And when we solve this out, we get AF equals to 10.198, which is our gain value. Now we're going to use the gain equation to solve for the RF and R2 values. And we know that this is a non-inverting op-amp because the VN is going into the positive terminal. So the gain equation will be AF equals to 1 plus RF over R2. And we know our AF, which we just found right here, which is equal to 10.198. So then when we subtract 1 to the other side, we get the ratio for RF over R2 is supposed to equal 9.198. So we can choose any values to plug in for those. So we can basically just make RF is equal to 9.198 ohms and R2 as equal to 1 ohm. And when you put the ratio of those, you get the gain of 9.198. From here, we have all of the values we need to plug into our circuit, and we have C1 equal to 1 microfarad, and R1, which we found over here, is equal to 159.15 ohms, and then we just found RF and R2 as 9.198 ohms, and R2 is equal to 1 ohm. And that's how you solve an active pass filter.